This is a video for OCR Pure Core Mathematics, Complex Numbers 4, de Moivre's theorem, 4.3, Powers of Complex Numbers in x plus iy form. Let's look at an example. Here we've got a complex number in the form x plus iy, and I want to find it to the power 4. Well, I could multiply this out the long way, using Pascal's triangle to give me the coefficients, and then sort everything out after that. But actually we know how to do this power, provided we have this in modulus argument form. So we're going to look at this complex number, and the easiest thing to do with that is to draw a sketch first of all, and it's 1 minus 1 over root 3i, so it's going to be somewhere down here. So it's a fourth quadrant angle that I'm going to be looking for. Now, my modulus is just equal to the square root of 1 squared plus minus 1 over root 3 squared. And in fact, we'll see that we don't need to worry about this minus sign, and we can in fact ignore it in future, because it's always going to be squared up and will become a plus. So that's going to be the square root of 1 plus 1/3, which is root 4/3, which is 2 over root 3. And the argument is going to be the inverse tan, that's arctan, of minus 1 over root 3. It's minus 1 over root 3 divided by 1. And that's equal to minus pi by 6. And minus pi by 6 is indeed this angle here, so it is a fourth quadrant result. So this thing is going to become 2 over root 3 times cos of minus pi by 6 plus I sine of minus pi by 6, and that's all to the power 4. Well, that's equal to 2 to the power 4 is 16, root 3 to the power 4 is 9, and then I'm going to get cos of minus 4 pi by 6 plus I sine of minus 4 pi by 6. Just simplifying that a bit, I've still got 16 over 9 cos of minus 2 pi by 3 plus I sine of minus 2 pi by 3. Well, the cos of minus 2 pi by 3 gives me minus a half, minus root 3 over 2. And so I get that, and so that's going to give me minus 8 over 9 minus 8 over 9i root 3. There's that working, tied it up for you. Just working it through, you can see here I get my final result. Okay, in this example we're going to look at 2 plus 2i to the 5, and I want that in the form x plus iy, where x and y are exact values. Okay, well, let's see what we've got. Starting then with 2 plus 2i, let's think about that. Well, if I draw it on an argand diagram, it's going to be there, first quadrant, and this angle here is going to be pi by 4. I'll quickly see that that's an isosceles right angled triangle, and that length there is going to be 2 root 2. It's just the diagonal of square of side 2. So I can rewrite this, that's 2 plus 2i to the 5, as 2 root 2 to the power 5 times cos of 5 pi by 4 plus I sine 5 pi by 4. Well, that's going to give me 2 to the 5 is 32. Root 2 to the power 5 is going to give me 4 root 2. And then from these, again, just think about a sketch of your Argand diagram. 5 pi by 4 is going to be there, third quadrant. So in fact, both cos and sine will be negative, and they're the same as the cos and sine of pi by 4. So they're both 1 over root 2, but they're both negative. So this is going to give me here minus 1 over root 2 minus 1 over root 2 I. Well, if we look at tidying up, I've got a common factor of root 2 on the bottom here, which is going to cancel with this root 2 outside here, so that goes with those. So I get 128 outside, and I get minus 1 minus I on the inside of the bracket. So I'm going to get minus 128 minus 128 I. Again, there's that working tidied up for you. So here's where we've established the modulus of the complex number and the argument for it, and then working that through, powering the modulus by 5 and multiplying the argument by 5, I end up with this result here. The next video in this sequence is 4.4 using de Moivre's theorem.